external pulling force. And in this case, you have to do the force analysis to calculate all the forces. Do we have any other forces acting on this object? W equals to mg, m, where m is 40 kilograms, and we have the normal force and frictional force. Okay. For part A, if the crate is originally at motion, so it's already at motion, so the static, so this should be the kinetic frictional force. Okay. And we know for the kinetic frictional force, it can be written as mu k n. And here, what is mu k? What's the number for mu k? 0.5. Okay. Okay, so now you can see this is quite a standard problem of the force analysis, right? So you have to decompose all the four forces and put them together into the x and y components of the Newton's second law. Okay. And in this case, you can see that the decomposition should be very simple because all these forces along x and y direction, right? So we should be able to write down the two equations easily, right? Okay, so x direction, here it should be f minus fk equals to max. And then y direction should be n minus mg equals to may. Okay? Yes, but hold 1 minute, then I'll ask you. Any question about writing the equation? Because I skipped the decomposition process. So I hope you still understand what I'm doing here. Okay? Sometimes, if the problem is quite simple, you can directly look at the graph and write down the forces. Here you have this force subtract this force for x direction, and here you have this force subtract this for y direction. Okay. And then, what we are going to do is to look at the acceleration. In this case, the acceleration is to like this, right? So we should have ax equal to what? And ay equal to
0.
0. So we get f minus fk equals to ma and n minus mg equals to 0, right? Okay, and if you look at the second equation, from 2, you should get n equals to mg equals to 40 multiplied by 10, which is 400 Newton, right? Okay, and then fk, in this case, should be mu kn, so equals to 0.5 multiplied by 400 equals to 200 Newton. And then the acceleration can be calculated from equation 1. From equation 1, then f, which is 250 minus 20 equals to 40 multiplied by a. So a equals to 50 over 40 equals to 1.25 meter per second. And that's the acceleration and the frictional force. Any question here?
1.25.
1.25. Okay, this is part A. Now let's look at part B. the crate is originally at rest and a horizontal pulling force of 250 Newton is applied.
Can you ever have both? If it starts at rest and begins to have motion, will you have both friction, static, and kinetic?
You cannot have both at the same time from the same surface, okay? Because you cannot have an object at the same time in motion and stay and rest. So for part B, you have very similar force analysis. Now you have, what is the force? 250 Newton, okay? And you have frictional force because it's originally and rest, so this is the static friction, okay? N and mg. Okay. Now, please note that we already discussed for static frictional force, you don't have one simple equation can write down like Fk equals to mu Kn, right? It's more complicated to calculate the static frictional force. So the first thing we have to do is to determine how can we calculate the static frictional force like this or like this. Okay? To calculate it in terms of the external force or maximum force. So what we are going to do, we have to calculate the maximum static frictional force and compare it with the external pulling force, right? So, okay, if we still write down the equation, we still have, this is F equals to 250. So we still have F minus Fs equals to ma and N minus mg equals to 0. We still have the two equations, but here instead of Fk we have Fs. Okay? So everything will be similar to that. And then again we can calculate the normal force N should be 400 Newton. Okay? Same calculation here from the second equation. And so Fs max should be mu s multiplied by n, so it will be 0.8 multiplied by 400 equals to 320 Newton. Okay, so that's the Fs max. Now, external force equals to 250 and the maximum static frictional force equals to 320. So what is the static frictional force? 250, right? Since F is smaller than Fs max, then Fs equals to F equals to 250. So basically, the only thing you need to do before you calculate the acceleration, you have to do some judgment like this. So you just need to compare the external force and the static friction, maximum static frictional force. And then the acceleration can be calculated from equation 1, where 250 minus 250 equals to 40 multiplied by 8. So A equals to 0. Okay? And that should be, right? Because the external force is smaller than the maximum static friction force. That means it's not enough to make the object to move. It's still there. So acceleration has to be 0. Any question here? Okay, please note that the only difference here for the two parts, one is the kinetic situation, another is the static situation. In both cases, you are applying the same amount of force, but you produce different kind of acceleration. Here is 1.5, Here is 0. And for part C, what happens is this time, it's still originally at rest, so its frictional force is Fs, but F equals to
400.
400 Newton. And you have N here, you have W equal to mg. Okay. Similarly, you are going to have the equation F minus Fs equals to ma, and N minus mg equals to 0. So from the second equation, you can solve for N equals to 400 Newton. These things will be the same, okay? What's different here is, okay, of course, the maximum static frictional force is Q, 320 Newton. Okay, so now the difference comes from, now this time if you compare the external force and the maximum static frictional force, which one is larger? 400 and 320. So in this case, the external force is larger than the maximum static frictional force, right? This is 400, this is 320. In this case, the static frictional force will be the same as maximum, right? Which is 320. So in this case, here, static frictional force is 250, A equals to 0. And here, maximum static frictional force is 320. Okay. If you use a different force to pull the object. And then the acceleration can be calculated from 400, this equation, right? Minus 320 equals to 48. So A equals to 2 meters per second. Okay. Of course, you should expect the acceleration shouldn't be 0 because now the external force is larger than the maximum static frictional force. So it should produce some acceleration. Okay. Any question here?